Okay, anyone? What was seen in previous classes? In the last three classes, we have seen some of the points. That is, we have completed point number 1, point number 2, point number 3, and we have started point number 4. What is the point number 1? Anyone?
Satellite subsystem.
Hmm? What is the point number 1? Attitude and orbit control. Okay. What is the actual meaning of attitude? What is attitude? What is an attitude? What is an attitude? What is orbit control? What is the attitude and orbit control of a satellite? Attitude is nothing but you don't know attitude. What is attitude? That is height of the satellite. Altitude is nothing but that is the height of the satellite. How much is the height from Earth to the particular space? That is calculated by the altitude. And orbit control is nothing but what? Orbit control. You have to control the particular path of the particular satellite where you are launching in the low Earth orbit, medium Earth orbit, or in the high Earth orbit. You have to control that particular path. That is the orbit. You have to control by using uh, monitoring at the Earth station. That is the attitude and orbit control. In that we have used two satellites. One is a spinner satellite, one is 3-axis satellites for controlling the orbit of the satellite. That is our first point, point number 1. And point number 2, we have seen a telemetry tracking command and monitoring. Telemetry tracking command and monitoring. What does that mean? Telemetry and monitoring. Anyone? Telemetry and monitoring. What actually they are doing?
Telemetry and monitoring means determining the condition of the satellite and measurement of the different parameters.
Very nice, very nice. Good, good, good. And what are the functions they are monitoring by sitting at the Earth station? What they are going to check?
Power provided by the
Yes. Power generated by the particular satellite. Next.
oven temperature,
Very nice, good. Next. How much is the power generated by solar panels? How much?
temperature of the parts and pressure in the fuel,
Very nice.
and the position of the parts.
Yeah, very nice. Good. That is to be done by telemetry and monitoring at the Earth station. After that, you have seen the tracking. What is tracking? What they are doing through tracking?
Determining the location of the satellite.
Very nice. Determining the location where it is heading, where it is located, and by using that, they are calculating the acceleration and they are going to calculate the velocity, and they are going to calculate the how much is the delay we are getting the signal from the satellite to the Earth station. Everything will be calculated by using the tracking. And the last we have seen the command. What is the function of command instead of Devkate? What is the actual function of command?
Ordering satellite to perform specific tasks.
Very nice. Ordering the satellite to do some operations. Okay. If they are monitoring and they are controlling the satellite by sitting at the Earth station, they have to give any order to the satellite. Okay. If the orbit of the satellite, if the path of the satellite is changed, they have to control by using by sitting at the Earth station, and by how they are controlling the orbit of the Earth satellite, they have to fire the thruster. By firing the thruster, the orbit of the satellite to maintain the stable, that is stationary. That is to be given the command to the particular satellite. And that is point number 2. And point number 3, what we have started, that is a power system. What is a power system? You have started yesterday, that is Saturday, that is power system. Power subsystem. Power subsystem, how many parts are there in this power subsystem? One is battery, one is
And
solar
another
cell.
one is solar panel.
Okay, nice, very nice. In the previous class, we have seen the batteries, about working of batteries, how they are working. When actually batteries are working, when the solar panels is unable to get any energy from the sunlight, that time the batteries are going to help for the satellite to become in a operation condition, in a function, to get the signal to the earth station, that the batteries will be done. And if the batteries are, how much is the volt actual rating of the battery is nothing but the rating of battery is of 20 to 50 volt, and it is converted into ampere, that is current, that is 20 to 100 ampere per hour. And actual efficiency of the battery should be minimum end of the satellite life. The end of the satellite life, they have to store the maximum amount of energy to the satellite, and that satellite, whatever the energy stored in the battery, that battery will going to use to operate the satellite in a particular direction and particular to give the signal to the earth station. This is point number 4. Power subsystem using two functions. One is two parts. One is batteries and one is solar panels. We'll see second. That is solar cells. Solar cells are nothing but that is panels. We are using two panels. One is right hand, one is left hand. That is solar cells are the elements that provides the whole communication satellites with the power to perform all of its tasks other than orbit control. The main important point in this, that only the function of power subsystem is to give the energy to the satellite to operate permanently, that is function permanently, that is very nicely, that is we are using batteries and solar cells. Instead of, they can't do the orbit control, they can't do the changing the path of the satellite. That's it is just, it has to give the power to the particular satellite, that's it. Solar cells are the elements that provide a particular energy to the communication satellites with power performed to all of its tasks other than orbit control. And second, the sun provides an amount of energy equal to approximately 1.361 kilowatt of power per square meter at the Earth's distance from the sun. There is some of the distance between the sun and the satellite. At the distance is a square in meter. When there is a square in meter, the maximum amount of the energy has to be provided by 1 square meter is of 1.361 kilowatt of power it is going to generate. And although Earth atmosphere absorbs a significant amount of this power, mostly around the ultraviolet region of the spectrum, whatever the energy is producing, if it is producing the more and more energy, that energy can also be used in the Earth atmosphere, and since satellites are in space, this is the amount of energy that they can theoretically get from the sun per square meter. Whatever the energy getting from the sun, that has to be calculated by using the square meter, and they are to calculate how much is the energy by using the sun. By attracting the sun, we are getting the maximum amount of energy. They are calculated every day. And how efficient are the solar cells? How much is the efficiency of the particular solar cells? The best solar cells in the market can only extract a fraction of the incident solar panel. In the fraction of seconds, it is going to give the maximum amount of power, and it is that power is converted into the electric power. We require the electric power to operate the satellite in a proper direction. So whatever the power is generated through the sunlight, that power is converted into the electric power. Typically, the best solar cells have an efficiency of 20 to 25% at the initial stage. At the initial stage, the efficiency of the solar cells will be 20 to 25%. How the years goes on, how the satellite life is goes on, how the satellite is becoming aging, this solar cells efficiency will be goes on decreases up to maximum of 15%. The efficiency goes on decreases how the years is goes on, how the satellite is becoming aging. At that time, the initial efficiency will be decreases at the final efficiency. The initial efficiency of the particular solar cells is of 20 to 25%. Once the year goes on, once the satellite goes on aging, that is the efficiency of the particular solar cells are becoming decreases. Next, change of solar cell efficiency with the time. Solar cells may have an efficiency as high as 25% when they are first manufactured. Now, this is the point. When they are manufactured at the initial stage, when they are going to implement in a particular satellite, the particular solar cell efficiency will be, that is 25%. However, with the time, this efficiency drops because of many factors. Why this efficiency decreases? We'll see that is for many factors, including aging. Aging is nothing but how the years are goes on, the satellite will become aged. That is aging, and the small scratches that occurs because of small meters that constantly hit them. Because whenever they are going to generate a particular energy, the sunlight, the energy is very high. It is going to hit particular panels of a particular solar cells, and when the sunlight is hitting every day, every second, every minute, so that particular efficiency is goes on decreases. Therefore, it is expected that the efficiency of a solar cell may drop from 25% to 50%. The initial efficiency is of 25% and the final efficiency is of 15%. At the last, 15% efficiency will be reduced. For example, at the end of the satellite life, the minimum age of the satellite is 10 to 15 years. 10 to 15 years. Minimum 5 to 6 to 7 years, the efficiency will be of 25%. When it is extended from 8 to 10 years, efficiency will be goes on, decreases. At the end of the life, at the 15 years, the efficiency will be become constant, that is of 15% of efficiency. Therefore, when building a satellite, it makes sense to have extra solar cell area to compensate for the expected drop in efficiency near the end of the satellite. What they are doing, they are going to install other set solar panels. When the efficiency decreases, it is unable to give maximum energy to the satellite to operate properly. At that time, they have to going to install one more solar panels with the supporting hand. One more solar panel as a supporting hand to get the maximum efficiency. So this is we are using a solar cells. Next, effect of solar cell direction on converted power. What it means, and when we are going to convert the particular power, what it is going to affect. Solar cells convert solar power to electricity. The more solar light a solar cell blocks, the more electric power that will be generated. Whatever the solar panels total energy were getting from the sunlight, it is going to convert into electric power. And solar cells that are directed such that solar rays hit them perpendicularly, not horizontally. It is perpendicularly to the plane which generate the maximum amount of power. A solar panel is having two hands. One is left side, one left hand, one is right hand. When the solar rays are hitting perpendicularly, it is going to generate maximum more and more amount of power. Whatever the power is generated, that power will be going to convert it to the electric energy. If the incident light and the line perpendicular to the solar cells are parallel, the solar cells will produce the maximum amount of power at any direction. They are going to provide a maximum number of directions, so it is rotating around the particular earth, so it is going to generate a maximum power when there is a sunlight. When there is a sunlight, the solar panels are active, start working. When there is no sunlight, if the energy is available, the satellite will be operated. If the energy is not available, the batteries are there to provide a particular energy to the particular satellite. So, what is the power required for the communication satellite? So, power needs of a communication satellite. The commercial communication satellites typically need an amount of power, from 5 to 10 kilowatts. Commercial is nothing but whatever the communication is going on, that is audio, video, you're sending any images, GPS system, everything that is commercial, require the maximum amount of power is of 5 to 10 kilowatts. Next, the total power generated by solar cells. Total power generated by solar cells on satellites. We are seen in point number 1. Point number 1 is attitude and orbit control. How we are going to control the particular orbit of the satellite that we are using. One is 3-axis stabilized satellites and one is spinner satellites. By using these two methods, the total power will be generated by using solar cells or solar panels. By using the two methods, one is 3-axis stabilized satellite, one is spinner satellite. What is this 3-axis stabilized satellites? 3-axis stabilized satellites have flat solar cell, that is a flat horizontal. The flat solar cell panels that are fixed on a rotating shafts. There is a rotating shafts are present in a particular solar cells. In a satellite, they are present in a particular solar cells to allow the satellite to always point its solar cells panels directly to the sun. 3-axis stabilized satellite is nothing but one is pointed towards the earth, one is pointed towards the solar panels, one is pointed towards the sun. 3 axis, one is earth, one is satellite, one is sun, and all these directions is going to provide the maximum power to the satellite. That is 3-axis stabilized satellite. Next, spinner satellites, however, have their solar cells covering its cylindrical surface. So solar cells have a cylindrical shape. Only one half of the total area of solar cells will be illuminated by the sun. Only half, one half of the, that is 1/3 of the area it is going to cover by using the sunlight produced by the sun. In addition, not all of the illuminated region will produce the maximum power. Whatever the illumination region present in a particular cell, it will not provide the maximum power, assuming that the solar cells on a satellite are directed to generate a maximum power. So they are going for a 3-axis stabilized satellites to generate more and more power to the satellite. This is what a concept of power subsystem. Power subsystem, we are using the two parts. One is batteries, one is solar panels. You have to remember the points, what actual the function of battery, what is the rating of the battery, and what is the efficiency of the battery, and what is actual function, what is the operation of solar cells, how much it is going to provide the particular energy to the particular satellite, what is the efficiency of the solar cell, initial efficiency and the final efficiency, and one final efficiency, how it is decreases energy, how the energy of the solar cells are decreases, why the efficiency initial is very high, why the efficiency of the final stage is less. Everything you have to remember. After that, what is the power required for a particular commercial communication satellites, how they are generating the total power to the particular solar cells by using the particular solar cells to the satellite by using through satellites, one is 3 axis, one is spinner. This is what the concept of point number 4, that is power subsystem. Power subsystem includes the batteries and solar cells. Solar cells are nothing but cell is having two panels, one is right hand, one is left right hand panel, one is left hand panel. This is the point number 4. Point number 5, very important subsystem, very important part present in a satellite, that is your communication subsystem. This many part we have seen in mobile communication, what is meant by transponder and how much is the frequency band and what is the frequency band of C, KU band, KA band, everything you have seen in this. That is a communication subsystem. A communication subsystem is the most important system of a communication satellite. That is right. The communication subsystem, everything will be going on only because of communication. So this part, this subsystem is very important in the satellite communication subsystem. All other subsystems are there to serve this subsystem. The remaining subsystem, that is power subsystem, that is attitude and orbit control subsystem, telemetry, monitoring, tracking and command, all these subsystems are going to support this communication subsystem. All these subsystems are going to support only and only one, that is communication subsystem. The basic building block of the communication subsystem is called transponder. Only one transponder is going to do all the functions, all the changing functions will be done by the transponders. The minimum transponders present in a particular satellites are 10 to 50 transponders present in a particular satellite. The basic building block of communication subsystem is called a transponder, which is basically a block. This is the definition, which is basically a block that receives a signal from the Earth station. Transponder, that basically a block that receives a signal from the Earth station, changes its frequency and amplifies it and then transmit it to another satellite or back to the Earth station. What is the definition of transponder? The basic main building block of this communication subsystem is transponder. The definition of transponder is to receive the signal from the Earth station, changes its frequency and it amplifies the signal and transmit it back to the other satellite which is present at the beside the satellite or to the Earth station. This is a basic building block of communication subsystem. Next, A, how many number of transponders required? The number of transponders in a communication satellite. A communication satellite contains from 10 to 50 transponders. This is minimum, not max. We can use a max number of transponders. How? The crowded region, that is if the population increases, if the more and more number of users are increases, at that time they are require more transponders. Depending on the population, they are going to decide how many transponders are required. A communication satellite contains from 10 to 50 transponders depending on how crowded the coverage region, means how much is the population in a particular state, that is going to decide, that is how crowded the coverage region of the satellite. In terms of customer requesting bandwidth on satellite, how much is the bandwidth required for a particular region, particular coverage region, that is depending on the bandwidth and many other factors. How much, what is the frequency band it is going to use for low Earth orbit, for medium Earth orbit, and for geostationary orbit, and bandwidth is goes on different for lower, medium Earth, and high Earth orbit. So depending on that, they are going to use more and more number of transponders. And if the population is minimum, how stable, they are using minimum number of transponders. What is the operation of transponder? We have seen in the point that is top. The operation of transponder. The transponder is simply a device. A transponder is simply a device that receives a signal from an earth station, amplifies it, and then sends it back to the earth station. This is the operation or function of transponder. What is the bandwidth required for transponder? The bandwidth of transponders. Transponders have different bandwidths, usually related to the band they operate at. They operate at. Typically, transponder bandwidths are 36 megahertz, that is C band. Yes, you have seen in unit number 1 the frequency bands, that is of very high frequency, ultra high frequency, L band, C band, Ku band, Ka band. These are the some of the frequency bands we are using. But in the particular satellite, we are using some of the bandwidths. That bandwidth is for C band and Ku band and Ka band mentioned here. It is typically the transponder bandwidths are 36 megahertz for C band, 54 megahertz for Ku band, and 72 megahertz for Ka band. Write down this one. That is important point for this is you have to write down the operation, that is the operation of the transponder, and what is the bandwidth required for particular bands, that is 36 megahertz for C band. Write down this 36 megahertz for C band, 54 megahertz for Ku band, and 72 megahertz for Ka band. Knowing that, what is the actual standard bandwidth of your television, that is TV, that is of 5 megahertz. The bandwidth of a standard definition TV channel is around 5 megahertz. Got it? The bandwidth of C band is 36, Ku band is 54, and Ka band is of 72 megahertz, and the bandwidth of your television is 5 megahertz. Next is, what is the difference between uplink and downlink frequency? Anyone tell me what is uplink? What is uplink?
The signal which is sent from Earth to satellite, that is uplink frequency.
Okay, what is downlink? Downlink.
The signal which is transmitted from satellite to the Earth station.
Very nice. That is the right question, right answer. That is the uplink is nothing but from Earth station to the satellite. The downlink is nothing but from satellite to the Earth station. There are frequency bands you are using. That comes at the last. You have to remember this uplink and downlink. They will ask you in the MCQ what is uplink. It is from Earth station to satellite. That is uplink. The downlink is from satellite to Earth station. Who is going to allocate its frequency? Who will allocate the frequency band of a particular country?
ITU, telecommunication unit.
Very nice. Right. ITU, that is International Telecommunication Union. This is the one of the organization. It is going to allocate a particular frequency to the particular country. Okay, that is, it would be a great if the same RF frequency is used for the uplink. But see the next point, it would be a great if same RF frequency is used for the uplink. The signal transmitted from Earth to the satellite. Uplink is nothing but what? The signal transmitted from Earth to satellite. And the downlink, the signal transmitted from satellite to Earth station. Because this would reduce the components in the transponder to a minimum. If it means what? If same RF frequency is using for uplink and the downlink, it is going to create some problem to amplify the signal that is present in a transponder. It is going to create a problem to the transponder to amplify the signal. For that, they are using a different frequency. Why they are using different frequency? Whatever the signal we are transferring from Earth to the satellite, that is of baseband signal. There is no modulation in that. So that is non-electrical signal. The transponder function is to convert that non-electrical signal into the electrical signal. If you are using the same frequency for uplink and downlink, it would be create a minimum problem for converting that signal to get the actual signal back to the receiver. For that, they are using a different frequency band for uplink and downlink. This will reduce some of the energy of the components present in a particular transponder. That is going to reduce, it is going to create a difficult in a particular part of the transponder. However, the use of the same frequency for the uplink as well as the downlink could cause a big problem in the amplifiers. There is amplifiers are present, encoders are present, and decoders are present. These parts present in a communication system, it is going to create some of the problem. Even if very highly directional antennas are used in the satellite for the uplink, even if you are using the highly directional antennas, but we can't use the same frequency for uplink and downlink. We can use the high directional antenna, no matter, but the frequency will be different for uplink and downlink. Even if very high directional antennas used in the satellite for the uplink and the downlink, there would be always be some leakage, signal leakage from the transmitting antenna on the satellite to the receiving antenna. We can't get the clear signal. The 99.9% of the signal will be reached to the particular station, but 0.1% of there will be a noise. The noise will be present in a particular, all the signals there should be a noise. The 0.1% of the noise should be present in almost all the signal if you are using the high directional antennas also. Since the signal received by the satellite are so weak, whatever the signal we are receiving from Earth station to the satellite are baseband signal. So those signals are very weak. The transponders use filters. The sum of the filters, it is using the transponder to remove the noise present in a particular signal. Transponders use filters of very high gain because it requires a high gain to remove the particular noise to convert non-electrical signal into the electrical signal. Even if a small amount of transmitted signal leaked to the receiving antenna at the Earth station, it would be highly amplified. Whatever the signal we are getting after removing the noise using the high gain antenna at the Earth station, that signal will be very highly amplified signal, which would cause even more leakages of the transmitted signal block the back to the receiving antenna. This would cause oscillation in the amplifiers. Oscillation means the variation in the signal. It would saturate, it will become stable, making the amplifier useless if you are using the same frequency band. If you are using the same frequency band for uplink and downlink, oscillation in the amplifier, it will become saturate, amplifier is become useless. The The only way is to avoid is to make sure that the transmitted signal has a different frequency. The transmitted signal has a different frequency from the received signal. Almost all the times we have to use a different frequency band for uplink and for downlink. Okay. The uplink and downlink frequencies of several frequency bands used in satellites are: one is C band. The uplink frequency is of 6 gigahertz. Write down this point, very important point. The C band frequency, the uplink frequency is of 6 gigahertz, and downlink frequency is of 4 gigahertz. That is 6 by 4. 6 by 4 is nothing but 6 is of uplink and 4 is of downlink. That is for C band. Next frequency band is Ku band. The Ku band, the uplink frequency is of 14 gigahertz and the downlink frequency band is of 11 gigahertz. Uplink is 14 and downlink. I will ask you the question tomorrow. Ku band 14 gigahertz for uplink, 11 gigahertz for downlink, and the Ka band 30 gigahertz and 20 gigahertz. These are the frequency band. In the previous PPT, we have seen the bandwidth. The bandwidth for C band is 36 megahertz. Ku band 54 megahertz. The bandwidth of Ka band 72 megahertz. Same thing, you have to use the frequency band of C band 6 by 4, Ku band 14 by 11, and Ka band 30 by 20 gigahertz. Okay, whatever the frequencies we are using, that frequency can be reused. We have seen in mobile communication frequency reuse. What is frequency reuse? किसी को याद है क्या? Anyone remember? What is
Using same frequency in code channel.
using same frequency?
Frequency range in code channel.
Code channel. Okay, right. The whatever the frequency you are using, that frequency should not be in adjacent channel. The same frequency can be used in a co-channel. Co-channel is nothing but it has to maintain some distance. It has to maintain some distance. The same frequency, thus one frequency used in one cell, the same frequency can be used in different cell with a maximum distance. That is frequency use. The same frequency cannot be used in adjacent cell. That is beside cell. That is a frequency use. By using many techniques that allow a single satellite to reuse the allocated bandwidth for it several times, a satellite with a bandwidth of 500 megahertz. The bandwidth of the particular satellite, whatever the frequency we are using, same frequency can be reused at the satellite also. And the bandwidth they are going to maintain is of 500 megahertz. The maintaining the bandwidth is of 500 megahertz. How much is the power required? The power transmission of a transponder is typically power transmitted by a transponder is around 200 watts. This is equivalent to around 20 watts per TV channel. The power required for this transponder is of 200 watts. Frequency conversion is transponder. There are two frequency conversions. One is single conversion, one is double conversion. What is single conversion of transponder? The frequency of the incoming signal, that is uplink, is directly shifted to the frequency of the outgoing signal. This is what? Whatever the frequency you are using, same frequency, it means what? Single conversion is what? If you are using the uplink is 4 gigahertz, same frequency you are using in 4 gigahertz at the downlink. This is what the meaning. The frequency of the incoming signal at uplink is directly shifted to the frequency of the outgoing signal at the downlink. Double conversion transponder. The frequency of the incoming signal at uplink RF frequency is first converted to a low intermediate frequency, that is IF frequency, then the frequency is shifted to the frequency of outgoing signal. See, this is what they are using the transponders. Double conversion, there is no maximum leakage in the signal. Single conversion, there is a more and more leakage in the signal if we are using the same frequency. That is, whatever the frequency you are using, directly shifted to the outgoing signal. The whatever the frequency you are transferring from our station to the satellite, that frequency is then changing it to the converted into the intermediate frequency, that is IF frequency. Then it is given to the Earth station. This is what point number 5, communication subsystem. Remember the point. Tomorrow I will discuss again. I will ask you the question. Last 2 points are remaining to complete this unit. Stop today. Give your attendance. Everyone give your attendance. Those who have given, I don't know, that is attendance, you from the lecture.